Hi, my name is Nur Alia Batisha binti Muhammad Shafi. My matric numbers is 2012610841 and I am from Am1101B.
Hi everyone, my name is Nasin Shokina binti Sharul Nizam and my student ID is 2026115407 and I'm from Am1101B.
Assalamualaikum everyone, my name is Natasha Am1101B, student ID 2026114313 and I'm from Am1101B.
Assalamualaikum and hi everyone, my name is Nur Aishaira binti Kamarul Zaman and my ID student is 2026109103. I am from Am1101B.
Introduction of compound interest. Compound interest is the process where interest is calculated not only on the original amount of money but also on the accumulated interest over time. This allows savings and investment to grow faster compared to a simple interest. Compound interest is commonly applied in fixed deposit account, saving accounts, and investment accounts. For example, a person who saves money in a fixed deposit account will receive interest every year, and the interest earned will continue to generate additional interest in the following years. According to economist Irving Fisher, compound interest is an important concept in financial growth and wealth accumulation. Irving Fisher in Theory of Interest.
The problem statement is Emma has been working as a marketing executive at Prohibition Solution for 2 years and now decide to save money for her wedding expenses by signing up for RHB Bank Ordinary Fixed Deposit Account. She intends to deposit RM6,000 for a period of 7 years and the account offers an interest rate of 1.70% compound every 6 months.
For case study 1, the first objective is to determine the accumulated amount at the end of Emma's saving period. The second one, to calculate the total interest received by Emma. The third one, to calculate the account balance at the end of the saving period when Emma deposited an additional in ringgit into the same account 1 year after her deposit. The last one, to calculate the accumulated amount at the end of the saving period when the interest rate changes to 1.90% every 2 months.
Objective 1. To determine the accumulated amount at the end of Emma's saving periods using the formula S equals to P multiplied with 1 plus I to the power of n. We substitute the information S equals 6,000 multiplied with 1 plus 7 over 800 to the power of 40. S equals to RM 6,778.30.
Objective 2 is to calculate the total interest received by Emma. So we use the formula I equals to S minus P. So we used all the information given earlier. So I equals to 6,778 ringgit 30 cent minus 6,000 and I equals to RM 778 ringgit and 30 cent.
Objective 3, to calculate the account balance at the end of the saving period when Emma deposit an additional in 2,500 into the same account 1 year after her deposit. P1 equals to 6,000, P2 equals to 2,500, T1 equals to 1 year, T2 equals to 6 years. K equals to 1.75% in bracket 010175, M2 equals to 2, N1 equals to MT1 equals to 2 times 1 equals to 2, N2 equals MT2 equals 2 times 6 equals to 12, I equals to K over M equals to 010175 over 2 equals 7 over 800.
For objective 3, the formula used by S equal P multiplied by 1 plus I raised to the power of N, which is the compound interest formula. In step 1, the formula S1 equals P1 multiplied by 1 plus I raised to the power of N1 was used to calculate the first accumulated amount. After the calculation, the total obtained was 6,105.14 ringgit. In step 2, the new principal amount was calculated using P new equal S1 plus P2. After adding the additional deposit, the new amount become 5,605.46 ringgit. In step 3, the formula S equal P new multiplied by 1 plus I raised to the power of N2 was applied again to calculate the final accumulated amount. Therefore, the final total obtained was 9,553 ringgit 81 cents.
Moving to objective 4, to calculate the accumulated amount at the end of the saving period when the interest rate changes to 1.90% every 2 months, 3 months during the period. So firstly, construct a timeline consisting of P, the principal amount, and S, the accumulated amounts. So P equals to 6,000 and S is what we will be calculating. For the first term, 3 months, which when we converted it to years, we will have 3 over 12 equals to 0.25 years. For the second term, 81 months, which when we converted it to years, 81 over 12 equals to 6.75 years. For the K1, equals to 1.75% or 0.0175. The frequency M1 equals to 2. I1, use the K1 over M1 equals to 0.0175 over 2 equals to 7 over 800. N1, we have to multiply M1 with T1. So 2 multiplied with 0.25 equals to 0.5. For the K2, 1.90% or 0.019. The frequency M2 equals to 6. I2 equals to K2 over M2 equals to 0.019 over 6, and we will have 19 over 6,000. N2 multiply M2 with T2, which 6 multiplied with 6.75 equals to 40.5.
And now we calculate the accumulated amount using the formula S1 equals to P multiplied with 1 plus I1 to the power of N. We substitute the informations. S1 equals to 6,000 multiplied with 1 plus 7 over 800 to the power of 0.5. S1 equals to Rm 6,026 and 9 cents. And finally, we calculate accumulated amount, which is S, using the formula S equals to S1 multiplied with 1 plus I2 to the power of N2. We substitute the information. S equals to 6,026 and 19 cents multiplied with 1 plus 19 over 6,000 to the power of 40.5, which is S equals to Rm 6,849 and 40 cents.
In financial mathematics, an annuity is a series of equal payments made at regular intervals over a specific period of time. A used car loan is a common example of an annuity because the borrower makes the same monthly payment each month until the loan is fully repaid. For example, When someone borrows money to purchase a used car, they agree to repay the loan through fixed monthly payment over a set number of years. Each payment includes for principal and interest, and the payments are made consistently according to the loan schedule.
Problem statement for case 2 is Ali plans to buy a used car for his daily transportation. He is interested in purchasing Produwa Alza 1.5 that is suitable for long distance travel. The cost of the car is 70,800. He plans to buy 20% as a down payment, and the remaining balance will be financed through a loan under a CIMB personal financing. The bank offers an interest rate of 4.45% compound monthly. The loan will be settled through monthly payment over a period of 7 years.
The first objective is to determine the amount of monthly payment paid by Ali. The second objective is to calculate the total interest incurred by Ali. The third objective is to calculate the total outstanding balance if Ali decides to settle the loan immediately after making the 60 seconds payments. Fourth objective is to determine the outstanding area that must be settled in the next payment if Ali has missed 3 consecutive monthly payments.
Result and discussion for case study 2. So first, we must construct the timeline, which consists A equals to 56,640 ringgit and R is unknown. For the cost price, CP equals to 70,800, down payment DP equals to 20% multiplied with CP, which is 70,800, equals to 14,160 ringgit. For the balance, B 70,800 minus with 14,160 equals to 56,640. For the K nominal rate equals to 4.45% or 0.0445. M equals to 12 and T equals to 7 years. For the I, we use K over M, which equal to 0.0445 over 12, and we will have 89 over 24,000. For the N, we have to multiply M and T. So multiply 12 and 7, we will have 84. Objective 1, to determine the amount of monthly payments paid by Ali, we use the annuity formula, which is A equals to R in bracket 1 minus in bracket 1 plus I to the power of negative N over I. So we rearrange the formula so that we can get R. So R equals to A multiplied by I over in bracket 1 minus in bracket 1 plus I to the power of negative N. So we just substitute the value into the formula. So R equals to 56,640 multiplied with 89 over 24,000 over in bracket 1 minus in bracket 1 plus 89 over 24,000 to the power of negative 84. You will get R equals to 785 ringgit 99 cents.
For objective 2, the formula for total interest was used, which is total repayments minus the original loan amount. From the calculations, the total interest incurred by Ali is 9,467 ringgit 16 cents.
Objective 3. To calculate the total outstanding balance if Ali decides to settle the loan immediately after making the 60-second payments with the formula N unpaid equals to N total minus N pay equals to 84 minus 62. N unpaid will get 22 with the formula AN equals to R brackets 1 minus bracket 1 plus I to the power of negative N over I. We will inserting the number to the formula. We will get A20. Answer for A22 is RM 9100. We will get answer for A22 is RM 1000. We will get answer for A22 is RM 199,652.86
Objective 4 is to determine the outstanding arrears that must be settled in the next payment if Ali has misses 3 consecutive monthly payments. The formula is N unpaid equals to 3 plus 1 equals 4. To calculate the balance, we will use the formula Sn equals to R in bracket 1 plus I the power of N minus 1 over I. S4 equals to in bracket 9,467 ringgit and 60 cents in bracket 1 plus 89 over 24,000 and the power of N minus 1 over 89 over 24,000, and the answer will be S4 equals to RM 37,520 ringgit and 50 cents.
In conclusion, this case study helped to calculate early monthly payments, the total interest charge, and the remaining loan balance after the 62nd payment. It also explains the amount of arrears that must be paid if Ali missed 3 consecutive monthly payments. Through this study, we can understand how annuity calculations are used in loan repayments and why proper financial planning is important to avoid payment problems in the future.